Hi everybody, welcome to 7.6, Systems of Linear Equations in 3 Variables. Hopefully by the end of this you will be able to solve systems of linear equations with 3 variables. So let's talk about visually what these look like and what the options are. So in general, when you have 3 variables, you aren't graphing lines anymore, you're looking at planes. Planes are, flat things that could continue in all directions, two-dimensional directions. And so you can kind of see some pictures here of different planes and how they intersect. So in A, you can see those 3 planes intersect at a single point. Whereas in B, those planes all intersect with a common line, so they have a line in common. In C, 2 of the planes are exactly the same, 1 and 2, and then they intersect with plane 3, and so they also intersect in a line. In D, all 3 planes are exactly the same plane, and so all of the points are in common. In E, we have parallel planes, and so they never intersect with each other, so that's no solution, there's no points in common. In F, 2 of the planes are parallel, and the third one intersects both planes, but because the plane 1 and plane 2 are parallel, there's no points in common at all, so that's no solution. In G, what's happening is that plane 2 and 3, they intersect to form a line, and that line is parallel to plane 1. And so what ends up happening is that those 3 planes never intersect at a common point. So there's no points in common in G either. And in plane H, 1 and 2 are the same plane and they are parallel to plane 3. So there's another no solution. So those are all of the different options. You could get a single point, you could get a line in common, you can get a plane in common, or you can get no solution, and that's visually what they look like. So how do you solve a system with 3 variables? In general, if you have 3 variables, you're going to need 3 equations to properly solve them. So most of the time, you're going to get these 3 by 3 systems, 3 variables, and 3 equations. What you need to do is basically, you have your choice. You can use substitution or elimination, whichever one you like better, or whichever one best fits the situation that you're in. So you can use substitution or elimination to combine 2 of your equations so that you just have 2 variables. And then you're going to do that again with 2 different equations to have the same 2 variables. So you want to combine them so that you get a 2 by 2 system of equations, so that you just have x's and y's, or x's and z's, or y's and z's, so that you have the same 2 variables in both of those little equations, both of those combination equations that you get from step 1 and 2. So after those 2 steps, you'll have a 2 by 2 system. And you can solve that either by substitution or elimination. And once you've solved for 1 variable, you get to use substitution to find the other 2. So let's give this a try. My main advice for you when doing this is to write everything out and to organize your work so that you can follow it and you don't get lost, okay? So for me, I really like to label my equations. Like that first equation, I'm going to call it equation 1. So equation 1 is x plus y plus z equals 2. Equation number 2 is x minus y plus 2z equals 2. Equation number 3 is negative x plus 2y minus z equals 1. So I'm going to try to eliminate a variable so that I can combine a couple of equations here. And it doesn't really matter. It looks like all of them are just as easy to eliminate. So how about we do equation 1 and 3 to eliminate the x's, okay? So equation 1 and equation 3 I'm going to combine together. Equation 1, again, is x plus y plus z equals 2. Equation 3 is negative x plus 2y minus z equals 1. This one's actually going to be really fun because my x's and z's are going to cancel out with this one. And so I'm just going to end up with 3y equals 3. And I can go ahead and solve for a variable at the beginning. That doesn't always happen, but I will take advantage of it while it's there. If I divide both sides by 3, I'll get y is 1. Well, I still need to find x and z, so I still have some work cut out for me, don't I? How about we combine equation 1 and equation 2. Let's see if we can find another variable. Because just with y is 1, I can't get x or z alone. So let's combine 1 and 2. So I've got x plus y plus z equals 2. And I've got x minus y plus 2z equals 2. Okay? And I'm using elimination, so I'm going to add my equations together. My y's cancel out. And now I've got x plus 3z equals 4. And that didn't really help me because I canceled my y's out. I probably shouldn't have done that. How about combining 2 and 3? That seems more helpful. So you can see how, well, I did something, but it wasn't as helpful as I thought it could be. So I'm going to try something else. What if I combine 2 and 3 together? What does that look like? Well, equation 2 is x minus y plus 2z equals 2. Equation 3 is negative x plus 2y minus z equals 1. And if I add those together, my x's cancel out, which is helpful. Negative y plus 2y would be positive 1y. 2z plus negative z would be positive 1z. And 2 plus 1 would be 3. That's helpful because I have y is 1, and I can substitute that right here for y. So now I've got 1 plus z equals 3, and I'll subtract 1 from both sides to get z is 2. So that's helpful. And then this other little equation, which I thought, oh, why did I do that? Now it's actually helpful because it'll help me find my x. So x plus 3z, and I just found z is 2, equals 4. 3 times 2 is 6. And if I subtract 6 from both sides, I'll have x is negative 2. And now I have all three pieces. I have x is negative 2, I have y is 1, I have z is 2. And I'll put that together as my answer. X is negative 2, y is 1, and z is 2. And that's the solution to this system of equations. This is a point that all three planes have in common. Alright, let's do another one. In example 2, you'll notice each equation only has 2 variables in it, which is kind of interesting. When they're set up like this, I think my natural tendency is to do some substitution instead of elimination. So I've got x minus y equals 6. That's my first equation. My second equation is 2y plus 5z equals 1. And my third equation is 3x minus 4z equals 8. Alright. So how about we do some substitution, because each one only has 2 variables, and that just seems easier to do some substitution with for me. So that first equation, I can add y to both sides to solve for x. So I'll have x equals 6 plus y. And then I can substitute that into equation 3. So this is equation 3 combined with that substitution from equation 1. So I'll have 3 times x, which is 3 times 6 plus y, minus 4z equals 8. And in case you're wondering, like, why are you doing this? You're still going to have 2 variables. I know, but I'm going to have the same 2 variables as equation 2, and that seems helpful. So from here, I'm going to distribute just to simplify this a bit. So that would be 18 plus 3y minus 4z equals 8. And then I'll subtract 18 from both sides just to simplify a bit more. So now I've got 3y minus 4z equals negative 10. So now this equation and my equation 2 have the same variables. They both have y and z, which is helpful. And from here, I can either continue using some substitution or I could use elimination. I think because now I'm kind of in standard form with both of those, I'd rather use elimination. So what I'm going to do is I'm going to take this equation And I'm going to multiply it by 5 so that I can cancel out my z's. So now I'll have 15y minus 20z equals negative 50. And then I'm going to take my equation 2 and I'm going to multiply it by 4 so that my z's will cancel out. So that'll be 8y plus 20z equals positive 4. And when I add those together, my z's cancel. 15y plus 8y is 23y. Negative 50 plus 4 is negative 46. And if I divide both sides by 23, I will get y is negative 2. So that's good. To get my next variable, I think right up here seems helpful. X equals 6 plus y. So x equals 6 plus y, which we just figured out is negative 2. 6 plus negative 2 is 4, so there's my x. X is 4. And then to get z, it doesn't really matter which one of these equations I use, but I need to use one of them. How about we use equation 2? Why not? So in equation 2, we'll have 2 times y, so 2 times negative 2, plus 5z equals 1. 2 times negative 2 is negative 4. I'll add 4 to both sides to work on solving my equation. So I've got 5z equals 5. And then I'll divide both sides by 5 to get z is 1. So now I've got my complete answer. I've got x is 4, y is negative 2, and z is 1. And there's the solution to that system. Now it's your turn. You guys get to try one and show me how much you've learned.